Okay, in this video I'm going to talk about the incorrect proof of the Dirac theorem like on this website. So there is this website ProofWiki, and it contains proofs of various theorems. And so when I was preparing for a video about the Dirac's theorem about Hamiltonian graphs, so I was reading this page, and so this is actually incorrect. So first, even the statement is incorrect. So it says here that a graph is, so it assumes that it's a connected graph. So everything else is correct. So for a connected graph of on n vertices, if the degree of each vertex is at least n over 2, then this graph is Hamiltonian. But the actual statement of the Dirac's theorem, it doesn't assume connectedness. So if you go, for example, to Wikipedia, so this is the page about Hamiltonian path, and the Dirac's theorem is given here. So you see here it doesn't assume that the graph is connected. So for any simple graph with n vertices, and greater or equal than 3, it is Hamiltonian if every vertex has degree n over 2 or greater. So this is the correct statement. It doesn't assume that it's connected. It would be connected, of course, as a conclusion, because if it has a Hamiltonian cycle, if it's Hamiltonian, it has a Hamiltonian cycle, then from this we can conclude that it is connected. But it has no assumption that it is connected. But here it does. So it is easier to prove the theorem when we assume that the graph is connected. And so when we look at the proof, so like technically for this statement the proof is correct. But we can see that it was adapted from the correct proof of the correct Hamiltonian theorem. Without assuming connectedness, because so generally the proof is, so we look at proof 1, because proof 2 is simply a simple corollary of the Oris theorem. So this is this is correct, of course. But so proof 1, the independent proof without using the Oris theorem, so basically, like, the proof goes generally the same way as I gave the proof in my video, but the last part here, the part when we proved that there is a cycle, that so we took the longest path and we proved that we can build a cycle on the same vertices. So from this, so basically this part, this is where they use connectedness. So they write, since G is connected, then there must be a vertex. So then we can extend an edge from this cycle, and then there would be a longer path than the original chosen longest path. So basically this is where they used connectedness, and this is simpler than in the actual proof. And we can see that this text was adapted, the text of this whole proof was adapted from the correct proof, because at the beginning they proved, basically because of this line, because at the beginning they proved that the length, the lower bound on the length of the longest path, basically this inequality, that k is greater or equal than n over 2 plus 1, because this is actually in the proof that they give, like with this using the connectedness, this inequality is actually not used. So this line is actually can be removed from the proof without any issues, because it is not used later. So like why do you prove this if it's not used? And the reason why they prove it, because they took it from the correct proof. The proof without assuming connectedness, and when we prove it without assuming connectedness, we actually need this at the end. So So that's how you can see that it was adapted from the correct proof. Yeah, so basically this part should be removed, replaced with another argument that uses this inequality. And the connectedness, the condition of connectedness should be removed from the statement. Yeah, so be careful when you read the proofs on the internet of like famous theorems. Like, be careful, because sometimes they are incorrect. Yeah, so that's it for this video.